After reading this chapter, there are a few things I have learned. I learned that the Earth has a heat budget, and the reason for this heat budget is so that Earth can maintain its constant temperature of about 16 degrees Celsius. To maintain this temperature, the Earth must radiate heat back out into the atmosphere as it receives heat energy from the sun. If this heat budget were to ever be offset, the planet would change dramatically. There is actually more heat gained over the equatorial latitudes, and there is more heat lost in the higher latitudes. I also learned that the actual angle at which the sun's rays strike the Earth changes dramatically from summer to winter. I did know already that the length of daylight changed from season to season. The solar radiation is actually different between the northern and southern hemispheres, meaning that when the north is experiencing summer, the south is experiencing winter. This can be shown by the higher values of solar radiation in the northern hemisphere during its summertime compared to the lower values of the southern hemisphere during its wintertime. I also learned that land and sea respond differently to solar radiation. The land actually has a low heat capacity because the rock and soil that make it up has a low specific heat, while the oceans have a high heat capacity due to water's high specific heat. So the ocean is actually capable of releasing and absorbing large amounts of heat without a drastic change in its temperature. I learned that when the sea surface rises up to form a hill, it's called a storm surge. And a storm surge is caused by a drop in atmospheric pressure and is about 95% wind driven. I also learned that a storm tide is formed from a storm surge colliding with a high tide. These storm tides can actually raise the water level by up to about 20 feet. Storm surges and storm tides are the greatest threat to life and property damage during a hurricane, which I also did not know. I also learned that a hurricane can only form on one side of the equator. If something similar forms on the other side, they're called typhoons or cyclones because the other side doesn't have the Coriolis effects to produce the spiraling winds that a hurricane has and is necessary to form a hurricane. I didn't know what caused a hurricane specifically before reading this chapter. I also didn't know that a hurricane was considered an intense atmospheric storm. Hurricanes are actually formed from the combination of surface water temperatures that exceed 27.8 degrees Celsius and when low pressure zones pump large amounts of energy from the sea surface into the atmosphere as warm air. The warm air actually rises rapidly and condenses to form clouds and precipitation. And due to the high rate of condensation, the storms produce strong winds and lots of rain. And to make things worse, the large amounts of heat energy from the condensation only fuels the storm and raises the wind speeds. The storm only begins to settle down as it moves over colder water or land. I thought it was interesting to learn all the different terms for ice, such as pancakes, ice floe, fast ice, drift ice, and pack ice. I didn't realize that ice was named based on where it is floating, if it's floating, or how thick it is. I thought ice was just ice. I thought it was interesting that as fresh ice is formed, the salt becomes concentrated in the underlying sea water, which increases its salinity and the density and causes that new ice to sink because regular ice would just float. So I thought that was interesting. It's also interesting that the difference between an ice floe and an iceberg is that an ice floe is less than 6 miles of floating ice, while an iceberg is a chunk of ice floating with about 12% of its area above the sea surface. They seem very similar to me. This probably isn't relevant at all, but something I'd like to learn more about is if these different kinds of winds, like trade winds and crosswinds, are one of the causes of why the Bermuda Triangle is so mysterious and why so many planes have issues going through it. I'd also like to learn more about the monsoon effect and the orographic effect. I think it's interesting to think about how precipitation changes in different elevations, and how airflow can cause increased condensation to form a monsoon. Some questions I have. The first question is, did the Titanic actually hit an iceberg, or is it possible that it could have hit an ice floe and drift ice? Did they have these terms back then to specify the difference? Second question is, will the ozone hole ever be completely repaired? And the third is, how do sailors make it out of the Horse latitudes if there is no wind to move their boat?